My friends, welcome to my weekend special series. Today I will be working on Model Mania 2018 as part of this weekend practicing on FreeCAD, and I am using the experimental the development version of FreeCAD 0.22, which will hopefully be released as the FreeCAD 1 version. Alright, so this is a SolidWorks developed model and we will be taking on it today. Build this model in phase 1 and then try to build the phase 2. After that we will do some FEM analysis on this, and I am thinking I'll be using connect tool hopefully. And so let's work on part workbench, and I think I will be building this leg first. Okay, so there will be a lot of cutting things away, and the sequence is really important in this one. So I'm gonna go ahead and bring in the axis cross and then relocate the image to the center of these two legs. Right, and we are ready to start sketching the leg. I think I'll be creating this leg with two sketches, one on XZ plane and another one from the YZ plane. On the XZ plane, it is simple. Let's take it all the way from here to there, right? And then let's bring in a line. Maybe I should use the polyline, right? So this length is 40, we know that. And then I want to use another arc of radius. This is the 24 one, okay. And from here to little past the axis, and now I'm gonna go ahead and add these two gaps. So this is on an angle, and we'll come back to fix that angle. For now, the outline is done, and I think I have not specified any radius to this one. This is 11, and that falls into place. The only thing left is the tangency between these two connections and the angle. So this is 7 degrees, so that's 97. Let's say, okay, 97, right? So that's a completely constrained sketch. I'm going to rename that as sketch leg from, this is XZ, right? And now I want to work on it from YZ. Okay, and this is going to move this image first and then draw a sketch on YZ plane. On the YZ, actually this is the diagram that I will be using, so I will have to relocate the image first there. Okay, now I can use, okay, so I can build this all the way up here and then come in somewhere about here and make an arc, right? Take it all the way up there and maybe connect it. Because I'll be doing intersection, there can be some extra lines here and there, like extra body, but on this sketch it is important that I capture these two edges perfectly, right? On the side by side should be perfect. Top and bottom, yeah, we can be flexible on that, right? So I'm gonna go ahead and place it on this axis and apply a 10 millimeter radius, and then this length So the overall length is 67. Yeah, I'll just make this one 27, right? Okay. And okay, let's go ahead and draw a circular hole in here with diameter 10, and I'm going to say this is 30. So because the overall length is 40, this radius is 10, that it makes it 30. Okay, we are missing something. I think making this symmetric will help. And then the angle, so this line is a 2-degree angle, so that is 92. All right, I think we got these where we want it to be. Pretty cool. Let's see, sketch leg, it was YZ. All right, so now we have two sketches. I want to extrude this sketch to cover this one, and I want to extrude this sketch both ways to cover this one. Let's go with this. Extrude that, say 25, right? And apply. It did cover the entire thing. Pretty cool. So this is leg YZ, and then hide that. Take this one and extrude this one for 25. Let's say symmetric, and it barely covers it, but it's covering it, so pretty cool. Leg XZ. Okay, the trick is pick these two and make an intersection, and that's a clean leg. There's another way to do that. That's the second way. I don't prefer it, but you can pick these two and go in here. This is the split objects tool, and then we can say slice apart, and that will create a bunch of slices, and we can keep hiding things, and there is our slice. So that's what actually the intersection does. I'm not going to do that. I'm going to go ahead and delete this. Okay, so we will do the intersection. It makes more sense, cleaner workflow. All right, we got this. Now I want to work on this center tube, because I'll have to take away things from here. I don't want to build that as a tube. I'll build a cylinder, and that cylinder will be radius 18 and 26 diameter, right? So the outside would be radius 13, and I think the height would be 27. I just used it a minute ago. Okay, so there is our one cylinder. I'm going to rename that as large, and then copy and paste it, rename that as small, and make the radius small. So this is going to be 9mm radius. Okay, there will be another cylinder, so take the small, or like take the big one, and this one is going to be horizontal cylinder, right? And this obviously we'll have to make it horizontal now, because the name says horizontal, and then move it backward, something like this. Maybe we'll have to increase the height at just a tad, so make the height say 35, right? And then the radius obviously is going to be smaller than 13, is 11. So we have these three cylinders in place. Now what I want to do, I want to make this cut at the last step. All right, so take this and mirror it over on the other side. So this is our leg, and mirror it over on the other side. So it is going to be YZ plane, and hit OK. So we got that. Now on here, I want to make these two one fusion. As usual, after every time I mirror it, I place them as a fusion. Now this time I can pick on the large cylinder and make all of them as a fusion. Okay, without these two cylinders, we have this. Now I want to cut away this mid part. So take this and take the horizontal cylinder and make a cut. And finally, take the small cylinder away, and there it is, our phase 1. Except the filleting. Now filleting, we will have to apply fillet on all edges, and it will have to be done sequentially. Let's pick these two edges first. I don't know why this new version, if I select this and control select the other edge, previously I could see that both of them are selected. Now these two are selected, but I don't see it. Like now see, these two are selected, but only one is highlighting. It's maybe one of my settings, I don't know. Anyway, now that these two are selected, let's go ahead and apply a 2mm fillet all around. Pretty cool. And then once this edge is kind of carved out, I can pick these two and make another 2mm fillet. So this is a sequential operation, and it must be a sequential operation. And then finally I take this one that goes all around and pick on that for a 2mm fillet. And that is our phase 1, my friend. Very cool. Okay, let's move on to phase 2 after I save it. Now let's look at phase 2. So the phase 2, maybe I'll place this on XZ plane. The phase 2 is different just a little bit on the idea and also the dimension, and that's why I wanted to talk about it when I have the phase 1 ready. So I want to overlap it, something like this. So now it is exact overlapping, and you can see the main changes are at two places. One of them is there will be a hollowed out part on the leg, so more like somebody is trying to optimize the material amount, and then also trying to increase this joint. So there will be more material on this tube part in the joint, in top to bottom, like vertically, but the arm will be less beefed up, will be some materials eaten away. So we'll have to think about it. So we cannot actually go and then just eat things away from here. We'll have to change the leg for phase 2. And I want to do that. And I don't think I'll be able to retain the fillet. Right now I want to delete that all together. And then I'll probably want to make them individual pieces. Alright, so we have every individual pieces now. Let's hide these cylinders. And I want to work on the leg. Okay, first of all, this is the XZ. I want to go ahead and edit that out. This one now has two centers of this object. So the 24 center is staying at the same place, but this 11 one, this radius, it's kind of moving downward. So what I want to do, I want to go ahead and delete that altogether. So that kind of frees up this, well, it did not. So take that constraint off and bring it down here. And then this 40 obviously will be changed to 32. right? So here, and now I can create an arc from this point. So this is going to be, and then I can come make these 2 points coincident, and that kind of like took the coincidence away from here. So let's put them back, and now we can go ahead and say this radius is 11, and I can say these two would be tangential, right? Things are moving here, and I can say that distance between these two centers is 8. So let's take this and apply an 8mm constraint. So the first sketch is updated. Let's keep it that way. Let's go to the second sketch, see if anything changes. I can see that the outside stays the same. So this sketch, we don't have to change anything on the outside because it doesn't have anything inside anyway. But we will have to, and we cannot make this hollow part away from here because this material is not eating out altogether. Right here, it's not eating out altogether. So what I'll have to do is I'll have to build another one of these, and so I can make a deduction from here. So let's go ahead and work on that. And I will be using these two sketches to help me actually build that another part. So let's copy these two and paste it. So these two are here now, and I'm going to go ahead and hide this leg altogether. Okay. Now we have is these two, and first of all, this XZ1. Okay, now I'll be using this diagram to help me think. Okay, so transform it this way. Oh, I did not reduce the transparency of this technical drawing, so that's why it's hard to see things. Let me go ahead and reduce the visibility to 50%. Okay, now it makes more sense. All right, almost there. Maybe just a little bit adjustment. Yeah, I would say that's better. On this line, on this XZ, what I want to do, I want to bring this line here, right? So I want to take this point on line constraint off, and that kind of brings it down. Okay, maybe we want to make this R 16 in place of, okay, so that's moved there. Now I can bring it right here. So we know this distance, but looking at this image, right, it doesn't matter if it goes all the way here. It doesn't matter. So let's keep it there. Yeah. So it's, we can eat that part away as long as there's something here. All right. I think that's it for here. Oh no, this 32 will have to be changed. We'll have to bring it somewhere here. Yeah, let's keep it, say 15. So I'm trying to cover this part, so as long as we are past this line, we are good. So that's our first edited sketch, and now I want to go place it on the YZ plane and work on the YZ, and we'll have to move things one more time. Or can we actually do it from here? Yeah, so there will be a 5mm wall here, and everything else remains the same. So I'm going to go ahead and make these two construction geometry, and then keep that reference from the center to somewhere here. and that radius is 10. Let's say this is equal to here, and then I obviously want to make this construction geometry as well and draw my own line. I want to make this distance perpendicular, so this is going to be 5, and then I can go ahead and make these two parallel. Right, all I have to do is make these two coincident. So that part is done. Now I can go ahead and make these two symmetric and make these two horizontal. Pretty cool. And now that I'm thinking about it, I can probably make this fillet working right here. That will be one less trouble to think about when we are actually building these. Let's go ahead and make a fillet out of it. Only these two edges. So I can go in and create fillet here and here. Obviously that eats away our constraints, which I wish they didn't. So this is going to be a 2 millimeter radius, and then we take these two, make a distance of 5 millimeter, and then we say these two are equal. Okay, and maybe make these two on the same horizontal plane. That fixes it. All right, so what we have here is a smaller arm, so we'll do the same thing. We'll extrude this one outward, say 25 worked last time, so we'll go with that, and this one will go with 25 as well, but it will be symmetric. And now I can go ahead and make these two an intersection. All right, so it says the use of non-solids for Boolean operations may lead to unexpected results. I know that these two are solids, but somehow it says it's non-solid, one of them, and only thing I can think of is these two. They are probably conflicting with each other. They should not. It happened to me one time before, so that's the only thing I can think of. So I'm gonna go ahead and take one of the sketches and maybe push it inside, say 1 millimeter. So that will give some overlap. Let's see if it worked. Yeah, it worked. So as I said, it happened to me one more time before, and that's the one way I think of it. Just push one of the planes from each other. That helps. Okay, so now we have this leg and we have another leg eating some part of that away, and we can make a deduction like so. I'll definitely reverse it, but this is what I'm looking at. This is what I'm looking at. That's the way to do it. Now think about this line. We will have to do a fillet in here, right? And which should be easy, but to remove the complexity from the process, what now I can do is I can go ahead and pick that line and apply a 2 millimeter fillet just right here. Yeah, I would rather do that here. So this is eat away leg. Let's make that deduction right now. And then, so don't worry about this thin 1 millimeter pad, it will be eaten away in our last phase. Okay, and now, so this is the new leg, and I can make a mirror of YZ plane there. And now we do the same thing that we did before. So take the large cylinder and make these three fusion. It worked. All right. And then take, oh, we'll have to relocate the horizontal cylinder. So it was 8 millimeter down. Remember that the difference between two centers was 8 millimeters. So in Z, say -8. That moves it downward, and that should work. Okay. So what I want to do, I want to take the small cylinder out of the fusion, and then finally, let's see. Maybe we'll have to do something about it. Okay, let's make this deduction, see if it works. It did not. You see, that small cylinder did not take away all the things that we wanted. So maybe go back to that small cylinder, increase the length or height, say 30 or even 40, and then maybe make it visible. We want to bring it down a bit more down, so transform it downward, something like this. So it, you know, I can see this whole circular thing at the end, and now I can hide it, and that's it. So there is our phase 2. Well, obviously we'll have to do some filleting, but this is our phase 2 essentially. At this point, if FreeCAD fails and I cannot do the filleting, I would still be saying we build this model in FreeCAD. Okay, let's get on with the filleting thing. We have everything that we did before, and then we have the inside ones. So we did already a couple of them in there. How about we do what we did last time? We pick these two and make a 2 millimeter fillet. Worked. And then we pick these two or these 4 and then make another 2 millimeter fillet. It worked. Okay. And now, or should we have been doing this one first? I don't know. So that's the only edge left. No, this one too. Okay, let's see. Take this one as an experimental. Say, oh, it did not work. All right. So reverse this fillet. Maybe we want to do this one first. And say 2 millimeter. Yes. So we did that. Now we can pick these two edges. This time we won't have to go around because this will come and make it all around. So take these two and make another 2 millimeter. So this is progressive. Ooh. Okay. Now for some reason it failed. So maybe smaller size fillet will work because it worked last time. Take this and take that. Make 1 millimeter fillet. 1 millimeter worked. So maybe the 2 millimeter was not working for some reason. Maybe this overlap, or I don't know. Let's push it, say 1.5. If 1.5 didn't work, we have 1 millimeter. So 1.5 worked too. How far we can go? 1.75. Still working. Maybe 1.99. Yeah, no, that didn't work. 1.75 worked. Okay, 1.75 worked. That's where we are at. And now we pick this edge and say 2 millimeter. It worked last time, should work this time too. So this is our phase 2 completed, built to the spec. The last assignment in model building is to do an FEM analysis. Here we'll have to fix these two cylindrical holes and apply 10,000 load on this upward, and we'll have to use plain carbon steel as our material. So let's go to the FEM workbench, and hide this. We don't need the technical drawing anymore. On this model, to do FEM analysis, we start with a container that already has a solver in it. If not, we can add a solver by clicking this S, and then add a material. So plain carbon steel, I don't think we have anything written as plain carbon steel in this material library. So I'm going to go ahead and pick 1C35. So this one has a yield strength of 300 MPa, which is good. Okay. And now I want to go ahead and fix these two surfaces and apply a load of 10,000. And this is just loading surface. We'll have to make it vertical. I think take this add off and select this edge, which is a vertical edge. Looks like it. And hit direction. So that way now it's going upward. If it didn't go upward, or rather it was in downward, we can select this reverse direction and that would reverse one way or the other. So we have the support, the load, the material, the model. Well, we don't have the model yet. We'll have to make a mesh. And I'm going with Gmesh first order with auto element size. Right, it took a minute and it has a warning, but the final line it says Gmesh done. And as long as it's not in red, I would like to go forward and see if it worked. So we have the material, load, force, and the model. Double click on the solver and start to run calculus. Okay, it was fairly quickly. The analysis was done only within 10 seconds. And now I can go ahead, take a look at the results. Looks like it's a complex model for my computer. I can hear the fans go, well, the computer fans go up when I try to move things away. So I want to hide this model, this pipeline, and obviously the mesh, I don't need it right now. And then go to CCX results, double click on it, that will show up the mesh. And here I want to take a look at the magnitude first. And it says the magnitude is very small, 7.6 micrometers, so very, very small displacement. On the stress side, the stress is also a small one, 65 MPa. For this material, we can go up to 300 MPa. So there is that. That's how this model will perform under the load. We want to see how this deformation comes into play. So because it's such a small deformation, I can scale it up to like 150 or 200 even and see how it moves. That's interesting. It's moving upward overall, but it's also squeezing things inside here. This kind of, so here, okay, look from this direction. Keep an eye on here. So obviously it's going upward, right? But like how the definition of Poisson ratio, it moves things inward on the side because it's stretching in the lengthwise. So if somebody wanted to know if this load is safe for this material on this model, the FEM analysis would say, yeah, it's way more than what the safe is looking for. The factor of safety is like more than 3 here. So which is what the main outcome of this FEM analysis. We can take a look at the deformation, see if that's any issue, or also we can look at the stress and see if the material will fail. With that, I think this is all we have to discuss on this material, on this model. If you have any other question on this on this model building or the FEM analysis, or if any suggestions to improve the process, please let me know below in the comment section of this video. I appreciate you taking time to suggest new things on this model building practice. With that, thank you for watching. I hope to see you in one of my next videos.